Hello, guys, welcome back to the new episode of C. In this episode, we will be learning about a memory leaks. What are memory leaks? So, let's start by defining a memory leak. A memory leak can occur when a programmer, or we can say a program, allocates some memory, and after the usage of that memory space, it forgets to deallocate that memory, and this memory is the memory which has been created by using a new keyword in C++, because the language like C++, where the programmers allocates and deallocates memory manually, and the C++ doesn't have its own garbage collector, we need to stay more vigilant about a memory, because if the memory leak happens, then we will be facing several issues. For example, our system get crashed because with time your program is running. Let's say your program is running continuously and creating some object. Yeah, and we can say that there is a program which contains uh, any profile. We can say a player profile, and every time when a player connects it to the server, it create a object of that player, and when the player get logged off, it not deleting the object of the player. So it means that every time when player gets logged in, the object has been created in a heap, or we can say by creating a new operator. But when the player logged off, the memory, we are not deleting that memory, and the memory will stays there, which which occurs a memory leak. So by time your memory gets full and your system will get crashed, maybe, or we can say the instability of our system can also happen. So how can we analyze a memory leak in our system? For example, you have a small system. In small system, you can analyze a memory leak easily. You can go through the code and or review the code, and you can see that where have you created a memory using a new keyword, and then you will check that I have deleted that memory or not. It's simple. But what if we have a big systems, or we can say a legacy systems, in which we have a lot of memory creation happening around everywhere in the code, and there are multiple people working on that code. Someone can make the mistake and leave create the memory and forgot to delete that memory. So it can like it occurs a memory leak. So there are multiple tools from which we can analyze a memory leak, and the most of the tools on Windows, specifically on Windows, are paid. On Linux, we have Valgrind, which is a good memory profiler, and which can easily find out that where the extra memory is using, and it identifies for us that where we need to look out and to check that this is the specific area where the memory is leaking out. So for the Windows, the most of the solution are, we can say, softwares are paid. So which so Visual Studio has a heap profiler in it. So we will be learning about a heap profiler of Visual Studio. So how can we use that heap profiler in an efficient way, which is a free tool to analyze a memory leak and fix a memory leak by just analyzing using a Visual Studio heap profiler. So let's start by writing a simple code of code which can do a memory leak. Yeah, again, it's not a big system. It's a small code I will be writing out in which there is a memory leak happening, to see how we can profile that memory leak and track that memory, that where is memory is leaking out. So let's directly jump into the Visual Studio editor and let's write a small piece of code which leaks out a memory. So let's start by creating a basic program of a memory leak. So let's add the header first. Let's add string and thread. We need these headers when we start writing our code, the actual code. And let's say chrono. Now first we need to create a two variables. So the first variable is the pointer variable to store our reference of a newly allocated memory. So let's declare a variable, pointer variable of int type, and let's name it as leaky ptr is equal to, and assign it with the null ptr at the moment. And then we will be creating one more declaring one more variable, which is the user input, which you will see why we are creating it. Now let's create a while loop, set it to true, and then let's take an input from the user. Do you really want to allocate a memory? So yes, no, or you can exit the program. Let's put a line break, and then let's add let's take a input from a user by using a get line. And there was a variable user input. After taking an input, the user will be adding three inputs. First is yes, second is no, or user can exit the program. If yes, so we will be creating, or we can say we will be allocating a new memory, or we can say we are going to create a new or creating allocating a new space using a new keyword of int type. So we have our variable, pointer variable leaky ptr. If the user provide with the input yes, we will use leaky ptr and create new int, and let's add some value, assign some value, let's add 10, and then let's output the value that we have assigned to our new allocated memory space. So is to get the value, we need to dereference our pointer, and leaky ptr. Okay, so the p is small, and then let's add a line break. Else if user input is no, we will simple continue to ask again. After that, else if user input is equal to exit, we will break, and else let's add some validations. We don't need that because we are using this program, but let's make some validations. Okay, so okay, so now we will be handling a case to deallocate this memory space. So now the after having this, like if this condition get fulfilled, it will come toward the next, and we can say let's add continue here. So if the user haven't provide with the correct input, the while loop will again go from the top. So now let's take the input again, or we can say same thing, but now it's a deallocation. And now the same thing we will be doing, or let's take copy both. And now instead of creating, we will be doing delete leaky ptr, and leaky ptr is equal to null ptr to avoid a dangling pointer. What is a dangling pointer? I will be explaining in some other videos in which I will be explaining about the pointers and the types of pointers. So, and if the user input is equal to no, then we will continue instead of doing something. So this is the whole scenario of, like, we can say, creation of the dynamic, or we can say allocation of the dynamic memory, and the deallocation of the dynamic memory. If the user doesn't deallocate the memory, then that memory remains there, it will not get deallocated. Now let's do one thing. When user try to exit the program, so we will do one thing. It's like leaky ptr, we will do here delete leaky ptr, and we should be adding if leaky ptr is there. If it's not there, if somehow the memory has been deleted, then it will crash our program. So we need to handle this case as well. So we will be doing if leaky ptr is present, then, and we need to do same here as well. And you can do one thing, deallocated, and instead of showing anything, let's keep it simple. Okay, and now like this, and same as the providing the dangling pointer, so I will assign it to null ptr. That's fine. So this is the whole code which will be running now, and now we will be seeing about the memory, or we can say the memory profiler tool of Visual Studio. So let's first build our code and see there are no compilation errors. I hope there will be no compilation errors. Okay, so there are no compilation error I can see. So let's run our program in a debugging mode. So it asking for a memory. So there are two things which we need to consider. First of all, you need to go in your debug menu, then you need to open Windows, and after opening a Windows, you need to click on this diagnostic tools, or we can say show diagnostic tool. This is diagnostic analysis. We need to see the diagnostic tools in which we can see the memory profiler, which is the process memory. The profiling is happening, and there is a heap profiling which is also enabled. So how can we see that how much space our program is taking at the moment? So let's make it like you need to take your first snapshot. I have taken a first snapshot. So the heap size is 99.51 KB and the allocation is 460. Let's click on this. It will give you the more view that what object type and what the count of those and what the bytes are allocated at the moment. So as you can see, there is an unresolved allocations. Don't go in this, and there is a memory profiling Visual Studio Container Proxy. Don't go, because we are just looking for our for our variable which we are creating inside a memory to allocate and deallocate and see the difference. So we have taken a first snapshot. Okay, now our program is running, so let's pass yes. It said the value allocated is 10, and now it's asking, do you really want to deallocate a memory? Before deallocating, let's take another snapshot. So we can see there is a plus 4, there is a plus 4. Let's click on this. So we can see there is a allocation of int which count is 1 and the size of byte is 4. As you know that in if we are creating, for example, there's this is the size byte of a integer, and creating in a memory the size of the integer which is 4 bytes. Now if we deallocate and take the another snapshot, we can see that it gets deleted. But at the moment, let's do okay, the value deallocated, right? Let's take another snapshot. We can see there is a -1. Now let's click on this snapshot. So we can see that our integer allocation is not showing now because it gets deallocated. Now let's do one more time, and now we can do multiple time. Like for example, yes, we have allocated one more space. Now we don't need to deallocate. Let's pass no. So we can see that if we take the snapshot, it's there, right? It's there. Integer is there. Now let's do that again. Now let's go on to our program and let's pass yes again to allocate one more space in our memory. When I enter yes, now take a snapshot again. So we can see there is plus one more. Now click on this. So we can see there is two integer present in our memory. So when we don't deallocate the memory, it remains inside our memory. So the basic concept of taking a snapshot and seeing that how much memory is allocated and how much memory is deallocating. So for example, if you have a big program and you have some features, for example, you have one feature of the you have a program of CRUD operations. Let's assume that. So let's see, if you are creating something and after the creation of that something you are freeing up the memory after the thing get completed or not. So you will be taking a snapshot before creation. After the creation you will take the snapshot and see how much bytes have been allocated into the memory. After the deletion happen in your program, then you will take the snapshot again to see that the allocated space which was done on the creation got deallocated or not. So this is how we can use the memory analysis tool or the memory diagnostic tool of Visual Studio, which is a good tool to analyze the memory profiling or the usage of memory and to prevent the memory leaks. But now in C++, there are smart pointers which prevents you from the memory leaks. But as we know that there is a lot of legacy code, we are working on it, and we sometimes we can see that there are legacy code which we already like we have written it some time in the past, and now they are raw pointers and we are creating a memory using a new keyword. So we need to analyze the memory allocations and deallocations to make your uh, memory leak free program. I hope you guys have learned a lot about a memory leak and a usage of a memory profiler in Visual Studio. Why I have explained you about the Visual Studio profiler is that because if you are doing if you are coding in Linux or using a C++ in a Linux, so there are other IDEs which give you more flexibility to profile your code and get the more optimized results. But if you're doing in Windows, the most of the tools are paid, and the most of the tools which are available are not giving you the accurate answer, or we can say the accurate results or accurate reports which can analyze that where the memory leak is. So that's why I tried a Visual Studio memory profiler, which really helps me and helps me to find a memory leaks in the code. So I hope you guys will also use this memory profiler to find out the leaks in your code. So thank you guys for watching this video. Do a leak-free programming. Don't forget to subscribe, like, and share my channel. Thank you guys.